Hi everybody, today we're going to take a look at the 45% concentration. So in your unit pack 4, if you can grab that out and go to the 45s, that's where I'll be working from. The first 2 pages of this are going to be like teacher demonstrated questions, so I will run through these 4. And then after that point, the next 2 pages were assigned as homework if you missed today. So follow along with the teacher ones. I'll kind of explain what's going on and how we're going to label things and do these types of problems. And then the back 2 sheets or the next 2 sheets would be homework. Okay? So today is going to be all about percent concentration. Way up at the top to the left, you'll see right by Oscar that we have this equation. We have mass of solute divided by the total mass of solution. And then in parentheses, you see that it says grams of solute plus grams of solvent. So this is the generic or general formula for percent concentration. We're always going to take the mass of what's dissolved divided by the mass of the total solution, meaning both the solute and the solvent added together. We multiply that by 100, and that'll give us a percent. So let's take a look at the first one here. In this first problem, the question is what's the percent concentration when 13.62 grams of sodium hydroxide are dissolved in enough liquid to make 133.85 grams of solution? So on the far right, you'll see we have three blanks. These 3 blanks are going to show up on every one of your sheets with these types of problems. We're always going to be looking for the grams of solute, how much was dissolved, the grams of solvent, in other words, how much of the water did we have, and then the grams of solution, which is going to be the solvent plus the solute. So in reality, if you really wanted to, you could kind of write this in. You could write it in where we have a positive sign right here and an equal sign right here. So the top 2, solute and solvent, are going to give us the grams of solution. So let's do this right away. We have a couple of masses in the problem. We see that we have 13.62 grams of sodium hydroxide. That's the solute. That's what we're dissolving. And then we also have 133.85 grams of solution. That's the total. Okay. And if we want to solve for the grams of solvent, we would take the total solution minus the grams of the solute and then that's going to give us the grams of solvent. So let's take 133.85 minus the 13.62, and that's going to give us 120.23 grams of solvent. Okay, that's the first step. The rest of this question is asking us to find percent concentration. That's where we're going to use the equation from up above. So up above we see that we have to take the mass of our solute divided by the mass of our solution and then multiply that by 100 to get our percentage. So let's take the pieces of information that we have and plug it in. Let's take the 13.262 grams of solute. Let's divide that by the 133.85 grams of solution. Let's multiply that by 100, and let's see what percentage that gives us. And you should get, with appropriate sig figs, we should have 4 sig figs, we should get 10.18%. And this is a percent concentration problem. So what we just solved for is the percent concentration of the sodium hydroxide in this solution. Okay? The next one's asking us, how would we make this solution? So previously, we talked about molarity and making solutions using volumetric flasks, and we had 6 steps in that process. In this process, when we know percent concentration, it's going to be a little simpler. All we really have to do is take the 13.62 grams of solute, we're going to add that to the 120.23 grams of solvent, which is water. And then step 3 is just going to be that we're going to mix it until they're homogeneous. So a little easier than the 6 steps. If we know how much stuff that we need to dissolve, we know how much water we need to dissolve it in, we just take those 2 quantities and mix them together. That's it. Let's go to the next one. In this one, we're asked for percent concentration again. We have 44.44 grams of strontium chloride, and that's going to be dissolved in 1,500 grams of water. So the idea here is that we have a couple pieces of information. Let's just fill them in off to the right away. The 44.44 grams of the strontium chloride is the solute, so we can write that in. Okay. And then the next one, it says it's water. So we have to be a little careful. In the first problem, we gave you the total solution. But in this problem, we're giving you just the water. So that's not the solution, that's actually the solvent. So the 1,500 goes on that second line. And now, if we want to find the total solution, we have to add those together. So we're going to take the solute plus the solvent, and that's going to equal our total solution. This is going to be 1,544.44 grams. Okay? So we still have to find the percent concentration. Let's set up that expression. That's always going to be the mass of the solute divided by the mass of the solution, and then multiply by 100. So let's take the 44.44 grams of solute, divide that by the 1,544.44 grams of solution. Let's multiply that by 100, and this is going to give us our percentage, which in this case is going to end up being 2.877% with 4 sulfates. Okay. So again, the next one after this asks us, how do we make this solution? I'm not going to write it out, but it's the similar 3 steps from earlier in the video. You take the 44.44 grams of strontium chloride solute, and we mix that with 1,500 grams of water, and then you just mix until they're homogeneous, and you're all done. So 3 steps. Take the grams of solute, add it to the grams of solvent, mix it, and you're done. Let's go to the next problem. A little different this time. In this problem, we have a couple different pieces of information that we haven't seen. We have a total volume of the solvent, or the solution rather, I'm sorry, and we have a percent concentration of the solute, or what's in there, but we also have a density. So this one's a different path, but we're trying to find the eventual same information. We want to figure out the grams of solute, the grams of solvent, and the grams of solution. In this problem, we don't have any of those yet, so we have to take a different route to get there. We do have the percent concentration, so we don't need to worry about solving for that, but we will need to use that expression to eventually get these pieces of information. So, on the front of your unit pack, you have the mole map, okay, and there's been a couple of things added to that mole map. We're going to use a bridge that we have not used yet. On the very bottom left of your cover, you have a bridge that's taking us from milliliters to grams, or vice versa. So the arrow between the grams island and the milliliters island is going to be density. So if you, on the front of your unit pack, if you haven't filled that in, please fill in that bridge from grams to milliliters or milliliters to grams is using density. And that's what we're going to do. So we're going to start with the 300 milliliters of solution here. The next factor we're going to use is going to be the density. So we'll have milliliters of solution on the bottom, grams of solution on top, and the values we plug in here are the density. We'll have 1.15 grams for every 1 milliliter. If we solve this, okay, we should get 345 grams of solution. That's going to go on the very bottom blank in our problem. Okay. To get the other pieces, we have to use that percent concentration. So we know that we have 300 milliliters total, or 345 grams total, and 5% of that is the solute, or what we dissolve. So the setup here is going to be the same as what we used previously. We just have a different unknown. What we don't have, and I'm going to work down below, I apologize, but I'm going to work down below so I have more space. So what we don't know is the mass of solute. We have the mass of solution. That's 345 grams. And if we multiply that by 100, we would get a percent. But we have the percent. We know the percent concentration from the problem. That's 5.00%. So at this point, it's really algebra. We have a mass of solute, which we don't know. That's your x value. So this problem really turns out to be x divided by 345 multiplied by 100 equals 5%. So let's solve for x. Let's isolate that variable. We're going to multiply both sides by 345. We're going to divide both sides by 100, and we'll be left with the mass of solute is going to equal our 5% divided by the 100 and then multiplied by the 345. So you plug this in, and we get a total mass of solute equal to 17.3 grams with sig figs. And that's what we're going to put on the very top line. Okay, so to get the solvent now, we just have to do subtraction. We have the total of 345. We subtract off the 17.3, and that'll give us the solvent. Because again, don't forget, the solution is the total. It's both the solute and the solvent added together. So this is really what we have. We're missing a piece. We're missing the solvent piece. So let's take the total, 345, and subtract 17.3. And that's going to give us a 328 grams of solvent with sig figs. So be careful with sig figs on that one. We're doing subtraction. So the 345 goes to the ones place. The 17.3 goes to the tenths place. Our answer can only go to the least precise, which is the ones, so 328 is correct. One more, and then I'm all done. Let's calculate the percent concentration if we have 0.4 moles of lithium bromide, and that's going to be dissolved in 180 grams of solvent. So right away, before we even start, we see that we have 180 grams of solvent. Let's just write that right in. Okay. In this problem, we don't have grams of solute, but we do have some other information about the solute. We know that we have 0.4 moles of solute. So to get from moles to grams, we've got to cross a bridge, and the bridge we're crossing is the molar mass bridge. So let's take the 0.400 moles of lithium bromide and set up a little factor label problem, and let's solve for the grams. We have the molar mass in the problem for us, so we know that it's 86.84 grams per mole. And this is lithium bromide. And if we plug this in, we should get that we need, or we have, 34.7 grams of lithium bromide. Okay. Lithium bromide is our solute. That's what we're dissolving. So we can write that way up top. Right there. Now to get the total mass of the solution, we just add those together. Solute plus solvent equals solution, so 34.7 plus 180. Again, we're using addition, so we have to be careful with sig figs. The first number goes to the tenths, second number goes to the hundredths. Our answer can only go to the tenths, so we should get 214.7 grams of solution. So again, we want the percent concentration. Let's set that up. That's always going to be mass of solute divided by mass of solution multiplied by 100. So we're going to take the 34.7 grams of solute divided by the 214.7 grams of solution. We multiply that by 100, and it'll give us a percent concentration. And with sig figs, we should only have 3 sig figs. You should get 16.2%. Okay? The very last question, much like the previous ones, is asking us to make this solution, and it's simply going to be the same 3 steps. We're going to take 34.7 grams of lithium bromide. We're going to add that to 180 grams of water, and we're going to mix that until it's homogeneous. Okay? I hope that was helpful. Obviously, if you ever need help, come find Mr. Scheidler or myself. We're more than happy to help you out. And then the homework is going to be the next 2 pages, 45.2 and 45.3.